All right, classes, a very important concept here, the difference quotient. And I don't know if we've covered this already. I know we covered this in multiple classes, so I want to give you one more example of this in case we haven't, just to make sure, because we're going to keep building off of this. And actually, calculus is built off of this. Okay? The difference quotient. Anytime we have a function, so I showed some wiggly function over here, and I have a point, x, f of x. There it is, right there. So we have this wiggle. There is my point, x and f of x. So obviously, the black wiggle right here is the function f of x. Okay? What we're going to do is we're going to add h to the x value. So I move along the x-axis here further, and I find this location over here. If I add h, that's x plus h. The height then, this location of this point, the height will be the value of the function at x plus h. Okay? So now I have 2 points that are on my function. Okay? The difference quotient, it just as it seems, difference, subtraction, quotient, division, we are going to take the difference of two things, and we are going to take on top and bottom, and then we'll take their quotient, and we'll get this. And I'll show you this in just a second here. Meaning I'm going to take this f of x plus h, and I'm going to subtract from it f of x. There's the difference, right? Quotient, we'll divide that by x plus h minus x. Now, I hope you guys realize, without technology there, hope you realize if this is a line, what we just found was this was f of x plus h minus f of x. I just subtracted the y's. This is x plus h minus x. I just subtracted the x's. What do we call that when we figure out the difference in the y's? The rise over the difference in the runs? The rise over the run? The slope? We just found the slope between any 2 points. And what did we talk about these 2 points? Well, one was on the function, the other one's on the function a little bit further. If h is positive, it's a little bit to the right. If h is negative, it's a little bit to the left. But I don't care, it's just somewhere else. This is what we call the difference quotient. Okay? So, the difference quotient for any function in one of the notations is simply f of x plus h minus f of x. Now some people should be clamoring here, x plus h minus x, that will just be h every time, because I'm adding an h and I'm subtracting x plus h minus x. Those will cancel out, and we have this. But I like to show it right away that it's just the rise over the run, and that is the difference of those two things. So that is what the difference quotient is, and that's where it comes from. Now I just want to show one example of what happens if, let's find a difference quotient for an actual function. Okay? And to do this, unfortunately I boxed myself into a corner here. We're going to have to take this out, and maybe this, and we'll just label this the dq right there. All right, and then let's go ahead and have my function be, I don't have the colors here, let's just let f of x equal x squared, I had a nice one here, but yeah, minus 4x plus 1. Okay, and let's find its difference quotient. So the difference quotient for that function is simply the value of the function at x plus h. Now this is the interesting part. I need to put x plus h into that function. So f of x plus h is x plus h squared minus 4 times x plus h plus 1. So we're going to put that in there. We're going to call this x plus h squared minus 4 times x plus h plus 1. Now we're going to subtract the function itself. We're going to subtract f of x. Well, that's f of x. So we subtract x squared minus 4x plus 1. And we divide that by h. This will equal, square it, let's make sure we take care of this, x squared plus 2xh plus h squared plus negative 4 times each of those. So we get negative 4x plus negative 4h plus the 1. Now we need to subtract the whole quantity. So be careful, when subtracting this whole quantity, we're going to get plus the opposite of x squared, plus 4x, plus negative 1. And all of that is divided by h. I can't use an equal sign not divided by h. You can't have the h leave and then have the h come back later. You know, you need to have each of these statements. This is the difference quotient, and it equals this, and it equals this. Now we'll try and clean this up a little bit. So I want to add like terms. There's a negative x squared. There's a positive x squared. Ho, ho! The x squareds are gone. Okay, let's see. I have two xh's. Any other xh's? No. So we're going to have two xh's. All right. I have an h squared. Any other h squareds? No. So I have an h squared. Negative 4x. Any other negative 4x's or any other x's? Yep, there's a positive 4x. Poof! Gone. And let's see, what do we have here? Oh, negative 4h. And that goes green because we have a negative 4h. And then the last one but not least, we have a positive one, we have a negative one. Poof! Those are gone. And this is all divided by h. What you notice is all of these have an h in common, so we can get the h out of there by dividing each of them by h, and we are left with 2x plus h minus 4. Notice, there is my difference quotient. And then, of course, for all of these, h can't be 0. If h was 0, we'd be dividing by 0, and then we wouldn't have two different points, we'd have the same point. So we'll let h be something. H should not be 0. For now. Okay? So there's an example of a difference quotient. Put one of those on there. Expect to be asked about doing a difference quotient. So practice this up. We'll get very good at difference quotients this year. Thanks.